Okay, this is Unit Test 6, solution video, and I'm going to start here with question number 7. And question 7 is an exponential equation. It says 9 to the x power minus 3 equals 24. So we see a constant here, and of course 9 to the variable x power. So that's why we refer to that as an exponential equation, because the unknown is an exponent. And it should be fairly apparent then that 9x equals 27, right? By using the property of the additive inverse and moving the negative 3 to the right-hand member, uh, where you get 27. Now, thinking exponentially about 9, we're going to rewrite that as 3 to the second power, and then that's being raised to the x power. And the right-hand side, 27, in terms of powers, is 3 to the third power. And then on the left, 3 squared to the x power. When you raise a power to a power, you multiply the powers. And so we have 3 to the 2x power equals 3 to the third. And since the bases are the same, the expressions as wholes are the same, we know that 2x is equal to 3. And so x is 3 halves, right? 1 and 5/10, 1.5. Okay. Now, question 8 is a log expression. And we're given the log of x plus 2, of the quantity x plus 2, is equal to 1. Okay? So from there, you need to understand this syntax. And uh, this refers to understood base of 10. And so what this is saying is 10 to the first power is equal to x plus 2. So we're converting from the log form to the exponent form, right? If we have c equals a to the b power, right? Then in this is an exponential form. Then in log form, what that's referring to is the log base of a of c is equal to the exponent b. And that's why we were saying in some of the videos earlier, it really helps to think log is, is as in equals, right? Exponent. Okay. So if you can frame it up in your mind that way, you realize when you're looking at a log expression, the thing by itself over here, that's an exponent. Now if we take that back to this exercise 8, log is exponent. They're saying that 1, that's an exponent. Okay? And the base, of course, is understood to be a 10. When it's a base 10, nobody writes it. Okay? And so this means 10 to some power is x plus 2. And they've identified what the power is. The power is 1. Now, from here, you're in elementary algebra, right? Because you just bring the 2 to the other side by the property of the additive inverse. And 10 minus 2 would be 8. So x is 8. Right? And if you look at that expression, what that's saying is log base 10 of 8 plus 2 is equal to 1. Well, that's then saying log base 10 of 10 is 1. Then again, reading this syntax right here, what that says is 10 to some power is 10, right? 10 to some power is 10. Well, what would that power be? Well, of course, that power would be 1. Okay, so a lot of people have a needed refresher and reminder on those log exercises, and that's fine. That's uh, that's what we're doing. That's what we're trying to do this summer is get you ready for the fall. And logs oftentimes have atrophied a little bit and what they're all about. So I forgot. Um, so we'll move on here to question 9. And 9, I'm going to rewrite this so it's a little easier to understand what it's saying. It's saying a to the minus 2 uh, times b all to the 1/2 power. So that 1/2 is an exponent right there. And then that's over a to the minus 4 power times a to the 3/2 power. And the first thing I'm going to do is use the power to a power rule right here, this numerator. And I'm going to get a to the minus 1, b to the 1/2 over a to the minus 4 and b to the 3/2. Okay. Now, from here, the exponent rules that apply, couple you could use, um, since you've got multiplied expressions here and a division of expressions with the same base, we can go with subtracting the exponents. In other words, we could use a to the minus 1 minus 4. Because when you divide expressions with the same base, you subtract the exponents. So I'm subtracting a negative exponent right there. And likewise on the b would be 1/2 minus 3/2. And of course, as we just mentioned, when you subtract that negative, that's going to be addition. So that's going to turn out to be a to the 3rd power. And the b, 1/2 minus 3/2 is going to be b to the negative 1. Now, that would be acceptable, except for the fact that they've asked us to remove the negative exponents, right? They've asked us to remove the negative exponent. And so at this point, I'm going to use the 1 over rule on this right here, on this multiplied b to the minus 1 power. And I'm going to rewrite this expression as a to the 3rd over b to the 1st power, because when you have something multiplied like that, you can move it to the denominator by merely changing the sign of the exponent. Of course, that 1 right there wouldn't be required. You wouldn't have to write the plus 1 there. So that's the exercise with those exponents. Number 10, we're back to an exponential equation. And we have 5 times e to the x minus 3 power equals 12. Okay. Well, this unknown exponent, right? The variable is an exponent, so it's an exponential equation. And the first thing I'm going to do is isolate that term that has that exponent on it. And since the 5 is multiplied times the e to the x minus 3, I'm just going to divide that from the left member and move it to the right and get 12/5. Just like that. Okay, so this multiplied 5 right here, just dividing that to the other side. Now I'm going to use logs, and since this is a base of Euler's constant, right? E, referred to as Euler's constant, it's about 2 7/10. Transcendental number like pi. Um, so instead of using log base 10, I'm going to use the natural log on both sides, which is denoted by an ln. So e to the x minus 3, and doing the same thing on the other side, using natural log of 12/5. Okay. And then the log of a to the b power, right? So I'm allowed to bring that quantity x minus 3 and multiply it times the natural log of e. And let's remember, when you have a log of some base of that same number, that's going to go to a 1. In other words, right here, this natural log of e, that means this, log base e of e. And of course, the log base n of n is always equal to what number? That's always equal to a 1. So this expression right here is going to go to a 1. All right. So we have x minus 3 equals the natural log of 12/5. And then we'll move the 3 from the left member to the right member and have natural log 12/5 plus 3. Okay. So there's our answer for question number 10. And we'll clean this up just a little bit. Get out our eraser and move on to question 11. And so we'll slide down the page a little bit here. And get my eraser out again here just to get rid of this line there. And this next one, look at the expression here on the left. 10 divided by 1 plus e to the minus x power equals. Now, just to start, you have a negative exponent. You might be thinking, okay, let's use the 1 over rule. But you see you have something added to it. So when you have something added on like that, we can't just move that to the numerator quite as simply. Um, you can do it, but it would take a little more effort because you do have a quantity added to it. So instead, I'm going to attack this as if it's a proportion. And of course, with a proportion, the common technique is to cross multiply. Multiply the extremes times the means. And we're going to get 10 when you do 10 times 1. And we're going to get 2 plus 2 e to the minus x. All right. So if you're okay with that, we'll now move the 2 to the other side by subtracting. You get 8 equals 2 times e to the minus x. This multiplied 2, I'll now divide and get 4 equals e to the minus x. And if everything's okay there, I have a variable exponent. I have the base e. And so, as we did in the previous exercise, I'm going to use the natural log to get the variable exponent down, right? Change my exponential equation into a multiplication equation. And so that allows me to write negative x times natural log e equals natural log 4. Okay. And again, that law, had a few people ask about this. That's log a to the b power. That's equivalent to b times the log of a. And so that's all that's being executed from here to here. Okay. again, we'll mention natural log of e is 1. So that's the advantage of using log base e, natural log. Right? And so we've got negative x equals the natural log 4. And so x would be the negative of the natural log 4. And that's exercise number 11. So hopefully you're happy with that. And again, clean things up here and look at question 12. We've got 1 equals 2 e to the 800ths x. And again, variable exponent. So it's an exponential equation. I'll isolate the term that has the variable exponent on it. And so I get 1/2 equals e to the 800ths x. And now we'll apply the natural log to both sides. So we have the natural log of 1/2 equals the natural log of e to the 800ths x. And then this exponent now becomes a multiplied expression. And finally, this natural log of e, seen it a couple times before already in this test, that natural log of e becomes a 1. Right? The idea being, if you do a log base n of n, that's always going to be a 1. All right? And of course, natural log means log base e. Right? So then from there, we divide by the 800ths. And so it's the natural log of 1/2 divided by 800ths. Okay. That's a final answer there, which is kind of a strange looking number, but that was the solution we were looking for. 13, we've got another factor exercise. This is from our very first unit, and I'm going to take a look at this done by way of the, just to refresh people's memories here, I'm going to take a look at this done by the AC method, which some people have been requesting on this one. They wanted to see this done again. So we've got 3x squared minus 5x plus 2. Now again, this is not an equation, so we're merely looking to factor the expression. And it's a quadratic expression. So a is a 3, b is a minus 5, and c is a 2. So the AC method says to multiply the a and c. That's how the method is named. And you might have referred to it, might have known about it, but not heard it referred to as the AC method. So the AC product is 6. Now the numbers that multiply to give me 6, when I multiply the 3 times the 2, I get 6, right? So the factors of 6 are 1 and 6 and 2 and 3. And then I have to compare those values to b. And b is 5, actually a minus 5, right? So which pair do you use? You could say, well, if I subtract 1 and 6, I get 5. And if I add 2 and 3, I get 5. So which pair do I select? Well, this is where you go back to your sign language. And right here, since the sign of the constant term is positive, I know that both signs have to be negative if I'm going to be able to factor this. And so I'm going to select, since the signs have to be the same, I'm going to select 2 and 3, right? The if this thing factors, it's going to have to be with a 2 and a 3. And then the next thing we do says to expand the middle. So I'll write it in as minus 2x and minus 3x. Those could have been reversed. Could have put the minus 3x first and the minus 2x behind it, and then the plus 2. So all that happened right here in this step is that this got exploded. Okay? And now the last step, pretty much, is to factor by grouping. And as you look at this first pair, they have x in common, pretty easy to see. And when you divide each term by x, you're going to have 3x minus 2. And the second pair, it doesn't appear they have anything in common, but because I have a negative sign right here, I'm going to factor out a negative 1. I'm going to divide out a negative 1. And by doing that, of course, negative 3x divided by negative 1 becomes plus 3x. And the plus 2 divided by negative 1 becomes minus 2. And of course, what that sets up is an identical expression in each piece of 3x minus 2. So from there, we factor out the 3x minus 2. And in this first term, you're left with an x. And in the last term, you've got a minus 1. And so there, in some order, was the factorization we were looking for. People's factoring appears to have improved over the course of the summer, and it certainly is a skill that will be invaluable in the calculus. So we've got 14 and 15 left here, and so we'll go back to those in just a moment. Clean this up first. Um, and so question number 14, 3 to the x minus x squared equals 1 over 9 to the x. So again, exponential equation. I'm going to rewrite the 9 to make it a common base with the 3. And so this is going to be written as 3 squared to the x power, which we can then express as 1 over 3 to the 2x power. Because when you raise a power to a power, you're multiplying the powers. And then I'm going to use the 1 over rule. So I'm going to move the 3 to the 2x to the numerator. And by doing that, I'm going to obtain 3 to the minus 2x. All right. Then from there, you have your common base. And so the x minus the x squared has to equal the negative 2x. And of course, quadratic, we think get one side to 0. So I'm going to move everything over to the right member and get now a positive x squared minus a 3x. Right? Because when you move this 1x over, we'll be subtracting it from a negative 2x, you'll get a negative 3x. And of course, the negative x squared moved to the right member will make it a positive x squared. From here, easy factoring, we get x times x minus 3. And out of that, two results, two solutions. One would be x equals 0. And the other, if x minus 3 equals 0, then the other solution would give us x equals 3. So two answers. And again, reminder there, when you're using WebAssign, if you have to put in two answers, you merely enter your two answers separated by a comma. That's how you enter things into WebAssign. You just enter the two answers, put a comma in between them, and that takes care of everything. All right. On to the last one, number 15. And it's a question from the second unit dealing with rational expressions. And we've got 2 over t minus 2 plus t over 2 minus t. And what we're getting at here, what we're trying to refresh, is that when you have two expressions separated by a minus sign, um, and the expressions have been reversed, then they are common by a factor of -1. That's to say, the denominator on the left of the expression is the signed opposite of the denominator on the right of the expression. This 2 on the left is negative. The 2 in the denominator on the right is positive. The t on the left is a plus t. The t on the right is a minus t. And so in order to add, we need a common denominator, and it's very easy to obtain. If on the right, for instance, I just multiply top and bottom by -1, so I'm multiplying by 1, then I will have a minus t, of course, in the numerator. And what that will accomplish with this denominator is it will make the 2 negative, and it will make the t a positive t. And I'll have obtained my common denominator. Now, next, of course, you have your t minus 2 common denominator. And the 2 from the left term and minus t from the right term. And we had a few students that stopped right there. Well, again, you're seeing the exact same situation you had with your denominators at the beginning of the problem. These two expressions, 2 minus t and t minus 2, are signed opposites. The 2 is plus, the 2 is minus. The t is negative, the t is positive. These two expressions are signed opposites, and so they can be canceled. That is to say, you could, for instance, factor out a -1 from your numerator, if you want to think of it this way. So if you factor out a -1, if you divide 2 by -1, that will be a -2, right? And if you divide -t, that's what you're doing when you're factoring, you're dividing. If you divide -t by -1, you will get plus t. And now, because multiplication and division are inverse operations, the t minus 2's can be canceled. And so the final answer in question number 15 should have been a -1. All right. So that's the solutions to 7 through 15. We hope you found them helpful. And if you have any questions, by all means, get back to us, and we'll see if we can help you out.